video introduces the basics of XML. XML can be thought of as a data model, an alternative to the relational model for structuring data. In addition to introducing XML, we will compare it to the relational model, although it is not critical to have watched the relational model videos in order to get something out of this one. The full name of XML is the Extensible Markup Language. XML is a standard for data representation and exchange, and it was designed initially for exchanging information on the Internet. Now, don't worry if you can't read the little snippet in the corner of the video here. You're not expected to at this point. XML can be thought of as a document format, similar to HTML if you're familiar with HTML. Most people are. The big difference is that the tags in an HTML document describe the content of the data rather than how to format the data, which is what the tags in HTML tend to represent. XML also has a streaming format or a streaming standard, and that's typically for the use of XML in programs, for emitting XML and consuming XML. So now let's take a look at the XML data itself. You see on the left side of the video a portion of an XML document. The entire document is available from the website for the course. The XML has three basic components, again, fairly similar to HTML. The first is tagged elements. So for example, let's take a look at this element here. This is an element saying that the data here is a first name. So we have an opening tag and we have a matching closing tag. We also have nesting of elements. So for example, here we have an element that's author. We have the opening tag here, the closing tag here, and we have a nesting of the first name and the last name elements. Even larger, we have a book element here with opening and closing tags with a nesting of numerous elements inside. And the entire document actually is one element whose opening tag is bookstore and the closing tag isn't visible on the video here. So that's what elements consist of: an opening tag, text or other sub-elements, and a closing tag. In addition, we have attributes. So each element may have within its opening tag, and let's take a look at the book element here, a set of attributes. And an attribute consists of an attribute name, the equals sign, and then an attribute value. So our book element right here has three attributes, one called ISBN, one called price, and one called edition. And any element can have any number of attributes as long as the attribute names are unique. And finally, the third component of XML is the text itself, which is depicted here in black. So within elements, we can have strings. We have the string Ullman here, we have a title here, here we have a remark. And so that's generally sort of, if you think of XML as a tree, the strings form, or the text forms the leaf elements of the tree. So again, those are the three major components of XML. Looks a lot like HTML, except that the tags are describing the content of the data and not how to format it. Now let's spend some time comparing the relational model against XML. Again, it's not critical that you've learned about the relational model, and you can skip this material if you're not interested, but in many cases when designing an application that's dealing with data, you might have to make a decision whether you want to use a relational database or whether you want to store the data in XML. So let's look at a few different aspects of the data and how it's used and how it compares between relational and XML. Let's start with the structure of the data itself. So as we learn, the structure in a relational model is basically a set of tables. So we define a set of columns and we have a set of rows. XML is generally, again, it's usually in a document or a string format, but if you think about the structure itself, the structure is hierarchical. The nested elements induce a hierarchy or a tree. There are constructs that actually allow us to have links within documents, and so you can also have XML representing a graph, though in general it's mostly thought of as a tree structure. Next, let's talk about schemas. In the relational model, the schema is very important. You fix your schema in advance when you design your database, and then you add the data to conform to the schema. Now in XML you have a lot more flexibility. So the schema is flexible. In fact, a lot of people refer to XML as self-describing. In other words, the schema and the data are kind of mixed together. The tags on elements are telling you the kind of data that you have, and you can have a lot of irregularity. Now, I will say that there are mechanisms for introducing schemas into XML, but they're not required. In the relational model, schemas are absolutely required. In XML, they're more optional. And in particular, let's go back and take a look at our example, and we'll see that we have sort of some structure in our example, but not everything is perfectly structured as it would be in the relational model. So coming back here and taking a look, first of all, we have the situation where in this first book we have an attribute called addition, the third addition, whereas in the second book we only have 2 attributes, so there's no addition in this book. Now, in the relational model, we would have to have a column for addition, and we'd have one for every book, although, of course, we could have null additions for some books. In XML, it's perfectly acceptable to have some attributes for some elements, and those attributes don't appear in other elements. Here's another example where we have a component in one book that's not in another, and it's this remark component. So here we have a book where we happen to have a remark, and incidentally, you can see that this remark suggests that we buy the complete book together with the first course. The first course is a subset, so it's not a very good suggestion, although Amazon actually did make that one. Anyway, enough of the asides. We do see that we have a remark for the first book, and we have no remark for the second book, and that's not a problem whatsoever in XML. In the relational model, we would again have to use null values for that case. And the third example I just wanted to give is the number of authors. So this first book has 2 authors. The second book, you can't see them all, but it has 3 authors. Not a problem in XML. Having different numbers of things is perfectly standard. So the main point being that there's a lot of flexibility in XML in terms of the schema. You can create your database with certain types of elements, later add more elements, remove elements, introduce inconsistencies in the structure, and it's not a problem. And again, I'll mention one more time that there are mechanisms for adding schema-like elements to XML or schema-like specifications to XML. We will be covering those in the next 2 videos, actually. Next, let's talk about how this data is queried. So for the relational model, we have relational algebra, we have SQL. These are pretty simple, nice languages, I would say. And it's a little bit of a matter of opinion, but I'm going to give them a smiley face. XML querying is a little trickier. Now, one of the factors here is that XML is a lot newer than the relational model, and querying XML is still settling down to some extent. But I'm just going to say, it's a little less, so I'm going to give it a neutral face here in terms of how simple and nice the languages are for querying XML. And we'll be spending some time in later videos learning some of those languages. Next in our chart is the aspect of ordering. So the relational model is fundamentally an unordered model, and that can actually be considered a bad thing to some extent. Sometimes in data applications it is nice to have ordering. We learned the order by clause in SQL, and that's a way to get order and query results. But fundamentally, the data in our table in the relational database is a set of data without an ordering within that set. Now, in XML, we do have, I would say, an implied ordering. So XML, as I said, can be thought of as either a document model or a stream model. In either case, just the nature of the XML being laid out in a document, as we have here, or being in a stream, induces an order. Very specifically, let's take a look at the authors here. So here we have 2 authors, and these authors aren't in order in the document. If we put those authors in a relational database, there would be no order. They could come out in either order unless we did a order by clause in our query. Whereas in XML, implied by the document structure is an order. And there's an order between these 2 books as well. Sometimes that order is meaningful, sometimes it's not, but it is available to be used in an application. Lastly, let's talk about implementation. As I mentioned in earlier videos, the relational model has been around for at least 35 years, and the systems that implement it have been around almost as long. They're very mature systems. They implement the relational model as the native model of the systems, and they're widely used. Things with XML are a little bit different, partly again because XML hasn't been around as long, but what's happening right now in terms of XML and conventional database systems is XML is typically an add-on. So in most systems, XML will be a layer over the relational database system. You can enter data in XML, you can query data in XML. It will be translated to a relational implementation. That's not necessarily a bad thing, and it does allow you to combine relational data and XML in a single system, sometimes even in a single query, but it's not the native model of the system itself. Now, you might have noticed that the name of this video is Well-Formed XML. So Well-Formed XML is actually the most flexible XML. An XML document or an XML stream is considered well-formed if it adheres to the basic structural requirements of XML. And there aren't many. It's just that we have a single root element, as we discussed before, a single bookstore in this case. that all of our tags are matching. We don't have open tags without closed tags. And our tags are properly nested, so we don't have interleaving of elements. And finally, within each element, if we have attribute names, they're unique. And that's about it. That's all we require for a XML document or a set of XML data to be considered well-formed. And for many applications, that's all we're concerned about. In order to test whether a document is well-formed, and specifically to access the components of a document in a program, we have what's called an XML parser. So we'll take an XML document here, and we'll feed it to an XML parser, and the parser will check the basic structure of the element, the document, just to make sure that everything is okay. If the document doesn't adhere to these three requirements up here, the parser will just send an error saying it's not well formed. If the document does adhere to the structure, then what comes out is parsed XML. And there's various standards for how we show parsed XML. One is called the Document Object Model, or DOM. It's a programmatic interface for sort of traversing the tree that's implied by XML. Another popular one is SAX. That's more of a stream model for XML. So these are the ways in which a program would access the parsed XML when it comes out of the parser. So one issue that comes up, because XML data is used frequently on the internet, is how we display XML. So obviously one way to display XML is just as we see it here, but very often we want to format the data that's in an XML document or an XML stream in a more intuitive way. And actually there's a sort of nice setup for doing that. What we can do is use a rule-based language to take the XML and translate it automatically to HTML, which we can then render in a browser. And a couple of popular languages are cascading style sheets, known as CSS, or the extensible style sheet language, known as XSL. We're going to look a little bit at XSL in a later video in the context of querying XML. We won't be covering CSS in this course, but let's just understand how these languages are used, what the basic structure is. So the idea is that we have an XML document, and then we send it to an interpreter of CSS or XSL, but we also have to have the rules that we're going to use on that particular document. And the rules are going to do things like match patterns or add extra commands. And once we send an XML document through the interpreter, we'll get an HTML document out, and then we can render that document in the browser. Now, one thing I should mention is that we'll also check with a parser to make sure that the document is well formed as well before we translate it to HTML. To conclude, XML is a standard for data representation and exchange. It can also be thought of as a data model, sort of a competitor to the relational model for structuring the data in one's application. It generally has a lot more flexibility than the relational model, which can be a plus and a minus, actually. In this video, we covered the well-formed XML, so XML that adheres to basic structural requirements. In the next video, we'll cover valid XML, where we actually do introduce a kind of schema for XML. The last thing I want to mention is that the formal specification for XML is quite enormous. There are a lot of bells and whistles. We're going to cover in these videos the most important components for understanding and using XML. In the previous video, we learned the basics of XML. In this video, we're going to learn about document type descriptors, also known as DTDs, and also ID and IDREF attributes. We learned that well-formed XML is XML that adheres to basic structural requirements, a single root element, match tags with proper nesting, and unique attributes within each element. Now we're going to learn about what's known as valid XML. Valid XML has to adhere to the same basic structural requirements as well-formed XML, but it also adheres to content-specific specifications. And we're going to learn two languages for those specifications. One of them is document type descriptors, or DTDs, and the other, a more powerful language, is XML schema. Specifications in XML schema are known as XSDs for XML schema descriptions. So as a reminder, here's how things worked with well-formed XML documents. We sent the document to a parser, and the parser would either return that the document was not well-formed, or it would return parsed XML. Now let's consider what happens with valid XML. Now we use a validating XML parser, and we have an additional input to the process, which is a specification, either a DTD or an XSD. So that's also fed to the parser along with the document. The parser can again say that the document is not well formed if it doesn't meet the basic structural requirements. It could also say that the document is not valid, meaning the structure of the document doesn't match the content-specific specification. If everything is good, then once again, parsed XML is returned. Now let's talk about the document type descriptors, or DTDs. We see a DTD in the lower left corner of the video, but we won't look at it in any detail because we'll be doing demos of DTDs a little later on. A DTD is a language that's kind of like a grammar, and what you can specify in that language is, for a particular document, what elements you want that document to contain, the tags of the elements, what attributes can be in the elements, how the different types of elements can be nested. Sometimes the ordering of the elements might want to be specified, and sometimes the number of occurrences of different elements. DTDs also allow the introduction of special types of attributes called ID and ID refs. And effectively what these allow you to do is specify pointers within a document, although these pointers are untyped. Before moving to the demo, let's talk a little bit about the positives and negatives of choosing to use a DTD or an XSD for one's XML data. After all, if you're building an application that encodes its data in XML, you'll have to decide whether you want the XML to just be well-formed or whether you'll want to have specifications and require the XML to be valid to satisfy those specifications. So let's put a few positives of choosing the latter, of requiring a DTD or an XSD. First of all, one of them is that when you write your program, you can assume that the data adheres to a specific structure. So programs can assume a structure, and so the programs themselves are simpler because they don't have to be doing a lot of error checking on the data. They'll know that before the data reaches the program, it's been run through a validator and it does satisfy a particular structure. Second of all, we talked some time ago about the cascading style sheet language and the extensible style sheet languages. These are languages that take XML and they run rules on it to process it into a different form, often HTML. When you write those rules, if you know that the data has a certain structure, then those rules can be simpler. So like the programs, they also can assume particular structure and it makes them simpler. Now, another use for DTDs or XSDs is as a specification language for conveying what XML might need to look like. So as an example, if you're performing data exchange using XML, maybe a company is going to receive purchase orders in XML, the company can actually use the DTD as a specification for what the XML needs to look like when it arrives at the program that's going to operate on it. Also, documentation. It can be useful to use one of these specifications to just document what the data itself looks like. In general, really what we have here is the benefits of typing. We're talking about strongly typed data versus loosely typed data, if you want to think of it that way. Now let's look at when we might prefer not to use a DTD. So what I'm going to describe down here is sort of the benefits of not using a DTD. So the biggest benefit is flexibility. So a DTD makes your XML data have to conform to a specification. If you want more flexibility or you want ease of change in the way the data is formatted without running into a lot of errors, then if that's what you want, then a DTD can be constraining. Another fact is that DTDs can be fairly messy, and this is not going to be obvious to you yet until we get into the demo, but if the data is irregular, very irregular, then specifying its structure can be hard, so especially for irregular documents. And actually, when we see the schema language, we'll discover that XSDs can be, I would say, really messy. So they can actually get very large. It's possible to have a document where the specification of the structure of the document is much, much larger than the document itself, which seems non-intuitive, but when we get to learn about XSDs, I think you'll see how that can happen. So overall, this is the benefits of no typing. It's really quite similar to the analogy in programming languages. The remainder of this video will teach about the DTDs themselves through a set of examples. We'll have a separate video for learning about XML schema and XSDs. So here we are with our first document that we're going to look at with a document type descriptor. We have on the left the document itself, we have on the right the document type descriptor, and then we have in the lower right a command line shell that we're going to use to validate the document. So this is similar data to what we saw in the last video, but let's go through it just to see what we have. We have an outermost element called bookstore, and we have two books in our bookstore. The first book has an ISBN number, price, and edition as attributes, and then it has a sub-element called title, another sub-element called authors with two authors underneath, first names and last names. The second book element is similar, except it doesn't have an edition, and it also has, as we see, a remark. Now let's take a look at the DTD, and I'm just going to walk through this DTD, not too slowly, not too fast, and explain exactly what it's doing. So the start of the DTD says this is a DTD named bookstore, and the root element is called bookstore. And now we have the first grammar-like construct. So these constructs are in fact a little bit like regular expressions if you know them. What this says is that a bookstore element has as sub-elements any number of elements that are called book or magazine. So we have book or magazine. We don't have any magazines yet, but we'll add one. And then the star says 0 or more instances. It's the cleany closure operator for those of you familiar with regular expressions. Now let's talk about what the book element has. So that's our next specification. The book element has a title followed by authors, followed by an optional remark. So now we don't have an or, we have a comma, and that says that these are going to be in that order, title, authors, and remark, and the question mark says that the remark is optional. Next, we have the attributes of our book element. So this Bang attribute list says we're going to describe the attributes, and we're going to have 3 of them, the ISBN, the price, and the edition. CData is the type of the attribute. It's just a string. And then required says that the attribute must be present, whereas implied says it doesn't have to be present. As you may remember, we have one book that doesn't have an edition. Our magazines are simply going to have titles, and they're going to have attributes that are month and year. Again, we don't have any magazines yet. A title is going to consist of string data. So here we see our title of First Course in Database System. You can think of that as the leaf data in the XML tree. And when you have a leaf that consists of text data, this is what you put in the DTD. Just take my word for it, hash PC data in parentheses. Now our authors are an element that still has structure. Our authors have as sub-elements, author sub-elements or elements, and we're going to specify here that the authors element must have one or more author sub-elements. So that's what the plus is saying here. Again, taken from regular expressions, plus means one or more instances. We have the remark, which is just going to be PC data or string data. We have our authors, which consists of a first name sub-element and a last name sub-element, and in that order. And then finally, our first names and last names are also strings. So this is the entire DTD, and it describes in detail the structure of our document. Now, we have a command. We're using something called XML lint that will check to see if the document meets the structure. We'll just run that command here with a couple of options, and it doesn't give us any output, which actually means that our document is correct. We'll be making some edits and seeing when our document is not correct, what happens when we run the command. So let's make our first edit. Let's say that we decide that we want the additional attribute of our books to be required rather than applied. So we'll change the DTD, we'll save the file, and now when we run our command, so as expected, we got an error, and the error says that one of our book elements does not have attribute addition. Now that addition is required, every book element ought to have it. So let's add an addition to our second book. Let's say that it's the second edition. Save the file. We'll validate our document again, and now everything is good. Let's do an edit to the document this time to see what happens when we change the order of the first name and the last name. So we've swapped Jeffrey Ullman to be Ullman Jeffrey. We validate our document, and now we see that we got an error because the elements are not in the correct order. In this case, let's undo that change rather than change our DTD. Let's try another edit to our document. Let's add a remark to our first book, but what we'll do is we'll leave the remark empty. So we'll add an opening and then directly a closing tag, and let's see if that validates. So it did validate, and in fact, when we have PC data as the type of an element, it's perfectly acceptable to have an empty element. As a final change, let's add a magazine to our database. You'll have to bear with me as I type. I'm always a little bit slow. So we see over here that when we have a magazine, there are 2 required attributes, the month and the year. So let's say the month is January, and the year, let's make that 2011. And then we have a title for our magazine. Here, we'll go down here. Our title, well, let's make it National Geographic. We'll close the tag, title tag. And then, sorry again about my typing, let's go ahead and validate the document. Oops, we saw a premature end of something or other. Oh, aha, we forgot our closing tag for magazine. So let's put that in, my terrible typing, and here we go, and let's validate, and we're done. Now we're going to learn about ID and IDref attributes. The document on the left side contains the same data as our previous document, but completely restructured. Instead of having authors as sub-elements of book elements, we're going to have our authors listed separately and then effectively point from the books to the authors of the book. We'll take a look at the data first, and then we'll take a look at the DTD that describes the data. Let's actually start with the authors. So our bookstore element here has 2 sub-elements that are books and 3 that are authors. So looking at the authors, we have the first name and the last name as sub-elements as usual, but we've added what we call the ident attribute. That's not a keyword. We've just called the attribute ident. And then for each of the 3 authors, we've given a string value to that attribute that we're going to use effectively for the pointers in the books. So we have our 3 authors. Now let's take a look at the books. Our book has the ISBN number and price. I've taken the edition out for now. And then it has this special attribute called authors. Authors is called an IDrefs attribute, and its value can refer to 1 or more strings that are ID attributes in another element. So that's what we're doing here. We're referring to the 2 author elements here. And in our second book, we're referring to the 3 author elements. We still have the title sub-element, and we still have the remark sub-element. And furthermore, we have one other cute thing here, which is instead of referring to the book by name within the remark when we're talking about the other book, we have another kind of pointer. So we'll specify that the ISBN is an ID for books, and then here, this is an IDrefs attribute that's referring to the ID of the other book. Now let's step through the DTD on the right that describes the structure of this document. This time our bookstore is going to consist of 0 or more books followed by 0 or more authors. Our books contain a title and an optional remark as sub-elements, and now they contain 3 attributes, the ISBN, which is now a special type of attribute called an ID, the price, which is the string value as usual, and the authors, which is this special type called IDrefs. Let's keep going. Our title is just string value as usual. Our remark here, this is an actually interesting construct. A remark consists of the PC data, which is string, or a book reference, and then 0 more instances of those. This is a type of construct that can be used to mix strings and sub-elements within an element. So anytime you want an element that might have some strings and then another element and then more string value, that's how it's done. PC data or the element type, 0 or more. Then we have our book reference, which is actually an empty element. It's only interesting because it has an attribute. So let's go back here. We see our book ref here. It actually doesn't have any data or sub-elements, but it has an attribute called book, and that is an IDref. That means it refers to an ID attribute of another element. Now we have our authors, the first name and the last name, and our author attributes have again an ID, and we're calling it the ident. And finally, the first name and last name are string values. This may seem overwhelming, but the key points in this DTD are the ID attributes. So the ID attributes, the ISBN attribute in the book, and the ident, wherever it went, ident attribute in the author are special attributes. And by the way, they do need to be unique values for those attributes. And they're special in that IDrefs attributes can refer to them, and that will be checked as well. Now, I did want to point out that the book reference here says IDref singular. When you have a singular IDref, then the string has to be exactly 1 ID value. When you have the plural IDrefs, then the string of the attribute is 1 or more one or more ID values separated by spaces. So it's a little bit clunky, but it does seem to work. Now let's go to our command line and let's validate the document. So the document is in fact valid. That's what it means when we get nothing back. And let's make some changes as we did before to explore what structure is imposed and what's checked with this DTD in the presence of IDs and IDrefs. As a first change, let's change this ID, this identifier HG, to JU. That should actually cause a couple of problems when we do that. Let's validate the document and see what happens. And we do, in fact, get 2 different errors. The first error says that we have 2 instances of JU. As you can see here, we now have JU twice, where ID values do have to be unique. They have to be globally unique throughout the document. The second error that occurred when we changed HG to JU is we effectively have a dangling pointer. We refer to HG here in this ID refs attribute, but there's no longer an element whose value is HG. So that's an error as well. So let's change it back to HG, just so our document is valid again. Now let's make another change. Let's take our book reference. We can see that our book reference is referring to the other book. We're in the complete book here, and the comment, the remark, is referring to the first course through the ISBN number. But let's change this string instead to refer to HG. So now we're actually referring to an author rather than another book. Let's check if the document validates. In fact, it does. And that shows that the pointers, when you have a DTD, are untyped. So it does check to make sure that this is an ID of another element, but we weren't able to specify that it should be a book element in our DTD, and since we're not able to specify it, of course, it's not possible to check it. We will see that in XML schema, we can have typed pointers, but it's not possible to have them in DTDs. The last change I'm going to show is to add a second book reference within our remark. So as I pointed out over here, when we write PC data or and an element type followed by the clean enclosure, the 0 or more star, that means we can freely mix text and sub-elements. So just right in the middle here, let's put a book reference. And we can put, let's say, book equals, I'm going to cheat again, just put JU, and that'll be the end of our reference there. And now we see that we have text followed by a sub-element, followed by more text, and so on. That should validate fine, and in fact it does. That completes our demonstration of XML documents with DTD. In this video, we'll be learning about XML schema. Like document type descriptors, XML schema allows us a way to give content-specific specifications for our XML data. As you may remember, we send to a validating XML parser our XML document as well as a description. We talked about DTDs in the last video. We'll talk about XSDs in this one. The validating XML parser will check that the document is well formed, and it will also check that it matches its specification. If it does, parsed XML comes out. If it doesn't, we get an error that the document is not valid. XML schema is an extensive language, very powerful. Like document type descriptors, we can specify the elements we want in our XML data, the attributes, the nesting of the elements, how elements need to be ordered, and the number of occurrences of elements. In addition, we can specify data types, we can specify keys, the pointers that we can specify are now typed, unlike in DTDs, and much, much more. Now, one difference between XML schema and DTDs is that the specifications in XML schemas, called XSDs, are actually written in the XML language itself. That can be useful, for example, if we have a browser that nicely renders the XML. The language, as I said, is vast. In this video, we're going to show one sort of, quote, easy example, but that example will give very much the flavor of XML schema, and we'll try to highlight the differences between XML schema and using document type descriptors. Okay, here we are with our XML document on the left. On the right, we have our XML schema descriptor, or XSD, and we have a little command line that we're going to use for our validation command. Now, let me just say up front that we're not going to be going through the XSD line by line in detail the way we did with DTDs. As you can see, it's rather long, and that would take us far too long and, frankly, be rather boring. So what I highly suggest is that you download the file for the XSD so you can look at it yourself and look at the entire file, as well as the XML, and give it a try with validating. What I'm going to do in this demo primarily is focus on those aspects of the XSD that are different, are more powerful than we had in document type descriptors. First, let's take a look at the data itself. So we have our bookstore data as usual with 2 books and 3 authors. It's slightly restructured from any of the versions we've used before. It looks closest to the last one we used because the books and authors are separate. And the authors are actually exactly the same. They have an identifier and a first name, last name sub-element. The primary difference is in the books, instead of using ID refs attributes to refer from books to authors, we now are back having an author's sub-element with the 2 authors underneath, and then those authors themselves have what are effectively the pointers to the identifiers for the authors. And we'll see how that's going to mesh with the XML schema descriptor that we're using for this file. So the other thing I want to mention is that right now we have the XML schema descriptor in one file and the XML in another. You might remember for the DTD, we simply placed the DTD specification at the top of the file with the XML. For DTDs, you can do it either way, in the same file or in a separate file. For XSDs, we always put those in a separate file. Also, notice that the XSD itself is in XML. It's using special tags. These are tags that are part of the XSD language, but we are still expressing it in XML. So we have two XML files, the data file and the schema file. To validate the data file against the schema file, we can use, again, the XML lint feature. We specify the schema file, the data file, and when we execute the command, we can see that the file validates correctly. So I'm now going to highlight 4 features of XML schema that aren't present in DTDs. One of them is typed values. One of them is key declarations, similar to IDs but a little bit more powerful. One is references, which are again similar to pointers but a little more powerful. And finally, occurrence constraints. So let's start with types. In our data, we see that the price attribute is denoted with a string, and when we had DTDs, all attribute values were, in fact, strings. In XSDs, we can say that we want to check that the values, which are still look like strings, actually conform to specific types. For example, we can say that the price must be an integer. Again, I'm not going to belabor the syntactic details, but rather I'm just going to highlight the places in the XSD where we're declaring things of interest. So specifically, here's where we declare the attribute price. And we say that the type of price must be an integer. So our document validated correctly. What if we change this 100 to be foo instead? Of course, with a DTD, this would be fine because all attributes are treated as strings. But if we try to validate now, we see an error. Specifically, foo is not a value of the correct type. So let's change that foo back to 100 so that we validate correctly. Next, let's talk about keys. In DTDs, we were able to specify IDs. IDs were globally unique values that could be used to identify specific elements, for example, when we wanted to point to those elements using ID refs. Keys are a little bit more powerful, or more specific, I should say. If you think about the relational model, a key in the relational model is an attribute or set of attributes that must be unique for each tuple in a table. So we don't have tables or tuples right now, but we do have elements, and we often have repeated elements. So similarly, we can specify that a particular attribute or component must be unique within every element of the same type. And we have 2 keys in our specification, one key which we can see here for books and one for authors. Specifically, we say for books that the ISBN attribute must be a key, and we say for authors that the ident attribute must be a key. So let's go over to our data, and let's start by looking at the authors. So if we change, for example, JU to HG, then we should get a key violation because we'll have 2 authors that have the same ident attribute. Let's try to validate. In fact, we do correctly get a key validation. We also get a couple of other errors, and those have to do with the fact that we're using these idents as the destination of what are effectively pointers or references. So let's change that back to JU, make sure everything now validates fine, and it does. Now let's make another change. So we have the ident being the key here, and we have the ISBN number being the key for books. What if we change the ISBN number to one of the values we used as a key for the authors, say to HG? When we did something similar with DTDs, we got an error because in DTDs, IDs have to be globally unique. Here we should not get an error. HG should be a perfectly reasonable key for books because we don't have another value that's the same. And in fact, it does validate. Now let's undo that change. Next, let's talk about references. So references allow us to have what are effectively typed pointers using the DTD. So they are called key ref, and here we have an example. Let me just change this to the middle of the document. So one of the reference types that we've defined in our DTD is a pointer to authors that we're using in our books. Specifically, we want to specify that this attribute here, the auth ident, has a value that is a key for the author elements. And we want to make sure it's author elements that it's pointing to and not other types of elements. Now, the syntax for doing this in XML schema is rather detailed. It's all right here. And just to give you a flavor, this middle selector here is actually using the XPath language, which we'll be learning later. But what it says is that when we navigate in the document down to one of these auth elements, within that auth element, the auth ident attribute is a reference to what we already defined as author keys. We've done something similar with books. We have our
book/remark/book-ref, that brings us down to this element here, and there we specify that the book attribute must be a reference to a book key, and the book key was earlier defined to be the ISBN number. Again, I know this is all complicated and the syntax is very clunky, so I urge you to download the specification and spend time looking at it on your own. Now let's make a couple of changes to our document to demonstrate how the checking of these typed pointers works. For example, let's change our first reference here to foo. Let's validate the document, and we should get an error, and indeed we do. The author key ref is incorrect. Now let's change that foo to JW. So originally it was JU, but now we're going to have two authors, both of whom refer to JW. Now this should not be a problem. It's simply two pointers to the same author, and we did not prohibit that in our XML schema specification, and indeed our document validates. We'll change that one back, and as the last change, we'll change our book reference here to refer to JW. This should not validate because this time, unlike with DTDs, we've actually specified typed pointers. In other words, we've specified that this pointer or this reference must be to a book element and not to an author element. So we'll validate, and indeed it fails. I've undone that change, and now let's move to the last feature that we're going to look at in this demonstration, which is occurrence constraints. So let me just bring up the first instance of it. In XML schema, we can specify how many times an element type is allowed to occur. Specifically, we can specify the minimum number of occurrences and the maximum number of occurrences. As a default, if we don't specify for an element the min occurs or max occurs, the default for both of them is 1. So here for books, we've said that we can have 0 books and we can have any number. So this is the maximum flexibility, any number of elements. For authors, we've also said we can have any number of authors. That's in the actual database itself. Remember that our bookstore consists of a set of books and a set of authors. But we are going to specify something a little different for how many authors we have within a specific book. So let's continue to look at other cases where we've specified occurrence constraints. Here's the case where we're specifying how many authors we have within a book. And again, phew, boy, this is really a lot of XML here. So take your time when you're looking at it, or for now, just take my word for it. What we're specifying here is how many sub-elements, how many auth sub-elements we have within each author's element. And here we have no min occurs specification, only a max occurs. That means by default, min occurs is 1. So what this is saying specifically is that every book has in its author sub-element at least one auth, but we can have any number of them. That's the string unbounded. Looking at the remaining occurrence constraints, for remarks, we have the minimum number of occurrences is 0. In other words, we don't have to have a remark. And we haven't specified max occurs. So as a default, max occurs is 1. So what we're saying here is that every book may have either no remark or exactly 1 remark, but it may not have more than that. And there's a few more occurrence constraints that you can take a look at, again, as you browse the XML schema description on your own. Now let's make some changes in the document to test these occurrence constraints. So first, let's remove the authors from our first book. We won't remove the whole authors sub-element, but just the 2 auth sub-elements of authors. We attempt to validate, and we see that it doesn't validate. We're missing some child elements, specifically the auth child elements, because we expected there to be at least one of them. Incidentally, if we took the entire authors sub-element out, we'll also get an error since we specified that books must have authors sub-elements. So now we're missing the entire author's structure in that book, and again, we don't validate. Let's put the authors back. And now let's take a look at the remark occurrence constraint. So we said that every book can have 0 or 1 remarks, so let's just add another remark to this book. Hi. Actually, remarks are allowed to be empty. In any case, we've added a small remark, we validate, and we see that we have too many remarks, again, because we specified that every book can have at most 1 remark. So that concludes our demonstration of XML schema. Again, it's been rather cursory. We've only covered a few of the constructs, but I did focus on the constructs that we have in XML schema that are not specifiable in DTDs. Finally, one more time, I urge you to download the XSD and the document and play around with it yourself.